What does a Greek philosopher have to do with your fretboard? Stick around, let's get nerdy. 12-tone music comes to us from Greek philosopher and mathematician Pythagoras. You most likely know him from being in high school in geometry class. You know, Pythagorean theorem, a squared plus b squared equals c squared. Pythagoras did a lot of nifty things. He developed this 12-tone system that was based on perfect intervals, or fifths. Now, it wasn't until, 1580 or so that there was a musician in China whose name I am not going to try to murder right now. You can look him up. This guy is the one that developed equal tempered tuning, which is what we use now. Back in the design series, I said that I'd show you how to do this eventually, and here today is that day. I showed you how to go onto stumac.com and to find their fret calculator, type in your scale length and the number of frets you wanted, and to hit go, and it would perfectly lay out the distances between each fret, the distance between, the nut to the next fret, or the bridge to the next fret. There are two equations that we see used to lay out fret positions. One is referred to the rule of 18, which is actually not 18, but 17.817. What we do is we divide whatever scale length you want, say 25.5, by 17.817. What that's going to give you is 1.431, which is going to be the distance between the nut position and the first fret. If we subtract that 1.431 from 25.5, that's going to give us 24.069. Now, we divide that by 17.817. That gives us 1.351. That's now the distance between your first fret and your second fret. Subtract that from your previous number, and so on, and so on, and so on. What you're going to notice, though, is whenever you get to your 12th fret, if our scale length is supposed to be 25.5, when we get to the 12th fret, the number should be 12.750, but you'll notice it's not. It's a little off. There's an equal tempered tuning method, or tuning equation, that we can use to get us perfectly in. And this is the one that the StuMac calculator uses. This particular equation is referred to as the 12th root of 2. How do you calculate that? Well, if you have a smartphone, particularly an iPhone like I do, you can go to your calculator, tap on the little icon for calculator, and hit scientific. When you do that, you'll see all these additional little buttons pop up. The one we want is y square root of x. What we will do is hit 2, then that button, then 12, and equals. The number we see then is 1.059463. This is the number we're going to use to get our equal tempered tuning. So if I take 25.5 and I divide that by my 1.0594631, and I hit equals, that's going to give me 24.069. Every time I hit equals, it will give me a smaller number. If I hit equals again, 22.718, 21.443, but you'll notice whenever I get to the 12th, it's going to give me 12.749999. If we round that up just a hair, that's 12.75. That's as close as we're going to get to being dead in the middle. And we continue that on. Every time I hit equals, it's going to give me a fret position. Now, that fret position is going to be from the other side, from the intonation point, and not from the nut position. In order to lay this out, we're going to need a few tools. Here's what they are: a pencil, a yardstick, some drafting paper, some tape, a protractor, some dividers or a compass, and dial calipers. Here, I've got a couple of center lines drawn, and then here's some nut position. I said that if we take our scale length and we divide that by 17.817, that gives us 1.431. Well, let's find 1.431 here on my dial caliper. So there's 1.431. I can go back, I can subtract that from 25.5, go through the whole process over and over and over again, which will take a while. And with each one of these little tick marks, I can come back in with my protractor and I can draw a perpendicular line. There's an easier way to lay this out without having to do all of the subtraction and division and individual measuring with the dial caliper. We still need the dial caliper for the very first measurement, which is 1.431 for 25.5-inch scale length. And what I'll do is I will come up at my nut position, 1.431 here. Then down here at this point, that's my 25.5. I will draw this long diagonal line from that 1.431 here to intersect down here at 25.5. Now I will use dividers. I will set first the dividers at this measurement here, this 4.431, and I will make this arc. Then draw a perpendicular line at that section. Now I will come back in and set my dividers to this length where it intersects that diagonal, and I will make another arc, and I will draw another perpendicular line, and so on and so on. This doesn't matter how many frets, you can go until your heart's content. We do this all the way down. Is it still easier to just go to StewMac and use their fret calculator? Yup, it sure is. But now you can see methods of doing it should you not have access to that. If you just really want to know, I mean, if you're a nerd like I am, then yeah, I gotta know how something works. It's not good enough for me to just type in a number real fast and it pops out this magic thing. These calculations will work for any scale length and any number of frets that you're going to want. This is also going to come in really, really handy whenever I show you how to do and lay out multi-scale. And that's exactly what we're going to do. We're going to lay out multi-scale and talk about how to do that. Cool? Until then, don't do anything weird. See you in a couple of weeks.